Now the chemical reactions can be of many types. In some, the two elements or an element and a compound, they just add up, combine. In others, a compound may just break, decompose. In still others, there may be a change of partners or the ions, to be more precise. So what we are going to study today is the types of chemical reactions. Types of chemical reactions. The commonest one is the combination reactions. Now you burn coal in air, what will happen? Coal is carbon, C plus O2. What do you get? CO2, carbon dioxide. So what has happened? The two have just joined together, right? Similarly, sulfur will give us sulfur dioxide. So these are simple combination reactions. Another one, CaO, that is quicklime plus water will give us CaOH twice, which means it is not just the elements that can combine, even the compounds can combine with each other. How is water formed? Which elements are present in water? Hydrogen and oxygen. So H2 plus O2 gives us water. Let's balance it. So two molecules of hydrogen and one molecule of oxygen give us two molecules of water. In all these cases, what we are having is a simple combination reaction. You can take some quicklime and add water to it. What you will get is calcium hydroxide, a base. So if you will put a red litmus paper, it will turn blue. So you will know that from quicklime and water, you have got lime water, which is just addition of quicklime and water. These type of reactions are called combination reactions. In the combination reaction, sometimes heat is released. For example, if you burn carbon, heat is released. If you burn methane, then also heat is released, plus heat. These type of reactions in which heat is released are called exothermic. Now when you add quicklime and water, or you can say when you add water to quicklime, then also it seems as if it is boiling. And if you touch it, it will be very hot. So lot of heat is released. So that is also an exothermic reaction. CaO plus H2O is equal to CaOH twice. If you want to dilute sulfuric acid, what will you do? Will you add water to sulfuric acid? Try it. You will be in difficulty. It will start boiling and there is every possibility that some drops may come on your face. So usually the precaution is that we add sulfuric acid to water, and that also very slowly. So that also is an exothermic reaction. H2SO4 plus water. So all these reactions in which heat is released is an exothermic reaction. So we can write it like this: heat released. Are there any cases in which heat is absorbed? Many, because when we heat a particular compound for a chemical reaction, heat is being absorbed, and such reactions are called endothermic. Heat absorbed. Endo means inside, exo means outside. So these are the reactions in which there is involvement of heat. Second type of reaction is in which a compound breaks down. For example, these reactions are called decomposition reactions. For example, if you heat calcium carbonate, what will you get? CaO plus CO2. So here the compound has broken down. You pass electric current through water, what will happen? You will get hydrogen and oxygen. So here also what has happened? Water has broken down into hydrogen and oxygen. Ammonia, this of course is a reversible reaction. A reversible reaction is written like this, half arrow in one direction, half on the other. What we get is nitrogen plus hydrogen. All these reactions are decomposition reactions. Silver chloride, silver plus chlorine. Same is true for silver bromide. Now when ferrous sulfate is heated, what we get is ferric oxide plus sulfur dioxide plus sulfur trioxide. Right? Now ferrous sulfate is green in color, but ferric oxide is not. Not only this, there is also pungent smell, that of sulfur dioxide. So there is change of smell also. When we heated lead nitrate, what did we find? Brown fumes coming. These brown fumes are that of nitrogen dioxide. So the equation is like this: lead nitrate, heat gives us lead oxide plus nitrogen dioxide plus oxygen. So now because it is NO3 twice, so nitrogen is 4, here also nitrogen is 4, oxygen becomes 12, and here we have 2, 8 plus 2, 10, and 2, 12. So equation is balanced. So in this way we find that some compounds, they break down on heating or under other circumstances, and then they produce new compounds. So such reactions in which there is a breakdown are called decomposition reaction. So I took different metals like say zinc, aluminium, iron, we can even take magnesium, and if possible copper and silver. So at this moment I have with me zinc, iron and aluminium, and then poured hydrochloric acid over it. What do we find? There is a release of a gas. But the rate of reaction is not same. It was much more vigorous in the case of zinc and much slower in the case of copper. In fact, hardly any reaction. So how does this reaction take place? Taking the case of zinc plus hydrochloric acid, what we find is that a salt is formed, zinc chloride plus hydrogen is released. What has happened? Hydrogen has been removed from the hydrochloric acid. It has been displaced by zinc because zinc is more reactive. Similarly, in the case of sulfuric acid, zinc sulfate and hydrogen will be produced. In both the cases, the hydrogen has been displaced. Such reactions are called displacement reaction. Now normally when acids and metals react, then metals are able to replace hydrogen and they produce salt and hydrogen is released. Now this is the case where only one element, or you can say one type of ion is displaced. Sometimes there is a displacement or there is a, you can say in simple language, change of partners. Now how is that? If you will pour sulfuric acid into barium chloride, what you will get is barium sulfate plus HCl. This is white precipitate. Now here what has happened? The reactants have changed their partners. Barium and sulfate have joined together, hydrogen and chlorine has joined together. So there is a displacement, or you can say replacement of ions. It is the ions that get displaced, and this is called double displacement reaction. Now what happens when an element combines with oxygen? Like in this case, or this case, or this case. Every time what we got was an oxide. Now what has happened? There is addition of oxygen. This is called oxidation. So we can say here carbon, magnesium or calcium has been oxidized. Oxidation is not only addition of oxygen. Removal of hydrogen is also oxidation. So either addition of oxygen or removal of hydrogen means oxidation. There is another complementary reaction, reduction. Reduction is addition of hydrogen or removal of oxygen. This is reduction. For example, N2 plus H2 is equal to ammonia. This is reduction. Now another aspect. Now when CuO, copper oxide, is heated with coke, what we get is copper and carbon dioxide. So what has happened? Oxygen has been removed from the oxide, and so what will we say? Is it oxidized or reduced? So we will say because there is removal of oxygen, so we will say it is reduction. So copper oxide has been reduced to copper. This is reduction. And what has happened to oxygen? It went and combined with carbon. So this was, we can say carbon has been oxidized. Carbon oxidized, CuO reduced. Even in the case of iron, same thing happens. Now this method is also used for extracting metals. When we are manufacturing iron or zinc, then we heat it with coke to convert oxides into their metals. When we will be doing metals and non-metals, we will study this more in detail. So actually speaking, oxidation and reduction go hand in hand. And when oxidation and reduction go hand in hand, the reaction is called redox. So we can say that oxidation and reduction go hand in hand. They happen simultaneously. So the fifth type of reaction is the redox reaction. There are some more examples of displacement reactions. And this can be shown with very simple experiment like I just showed you. We take copper sulfate solution. Copper sulfate is blue in color as you saw. And then we put iron nails in it. After some time, what we found? Iron nails were brown in color. Why? copper got deposited on them because iron replaced copper. So what we got was iron sulfate plus copper, and copper got deposited on the iron nails, and ferrous sulfate solution is green. So the solution turned from blue to green. So actually what has happened? Iron has displaced copper from its compound. Why? Because iron is more reactive. When you will study activity series, you will find the exact order in which we place them according to their reactivity. Then you can also do that, you can put some zinc in copper sulfate. Even zinc is more reactive than copper, so it will replace copper, and what we will get is zinc sulfate plus copper, and zinc is white. So though zinc is also slightly brown, but because copper is more reddish brown, zinc will get coated with reddish brown color. So in these cases what we have seen is that this has been able to displace. Then if you take copper chloride and lead, what you will get is again lead chloride and copper. So all these lead, zinc and iron were able to replace copper. Why? Because they are more reactive than copper. But if we would change the method, and if we take ferrous sulfate and put copper in it, there will be no reaction. FeSO4 plus copper, no reaction. Why? Because copper cannot displace iron, because it is more reactive. Now say if there is a monitor in your class and he is doing very well, and a new student comes who is better than him or her in behavior, in academics, in co-curricular activities. So what happens? The teacher decides, okay, we can make him the monitor. So this one has displaced the old one. But if the new entrant was not so bright or was not so able to take initiative, then he will not be able to. So just in this case, the metals which are more reactive will be able to replace, and which are less reactive will not be able to replace. Now what is the advantage? The advantage is in the case of noble metals, silver and gold. That is why especially gold is not influenced or affected by the presence of oxygen, water or acids, because gold is comparatively a very non-reactive metal. That is why it is valued so much. If you have silver jewelry, after some time, what do you find? It has turned black. Your copperware or the things that are made up of copper, they become slightly greenish. The aluminium turns dull. Why all this happens? What is this phenomenon? That is our next topic.